maybe some of you out there, we did this maybe 6 months ago or so. And I put together a presentation specifically for you guys based on what Rachel had requested. And so the thrust of it are about making sense of cracks. And then there's going to be certainly at any point, if somebody has a question about cost of repairs, we can talk about that or any other questions that come up. Briefly about me, if you see in the slide, Greg Kemp, comma, PE, PE means professional engineer. Pretty much in most areas of the country, that is the license you get, professional engineer, and an engineering that allows you to practice in the area that you feel competent. And so my background is kind of broad, but it's mostly related to structures. I do have specifically early in my career, it was marine structures, piers, bridges, and that kind of thing. I do have some other civil engineering experience that's kind of a side to it related to some highway stuff and other things. But mainly it's been structures and inspections of structures. My business, my main business is Kemp Home Inspections. That operates also under the DBA, doing business as ASA Engineering Group. And the difference is it's called Kemp Home Inspections because I used to actually do full home inspections. But now that business is really me doing targeted structural inspections of residential properties. I do a little bit of commercial also, but mostly residential. ASA Engineering Group is the same company, it's just another name. That's specifically where I work with home inspectors like Rachel and Lodestar in having them collect structural data from houses that they're inspecting and send it to me so I can produce engineering reports without always having to go to the property. I'm going to go a little bit quick. If you need me to slow down, let me know.
And
so
you said, Greg, you've got like the first 15 minutes is like building up and then the rest is going to be pictures and stuff like that, right?
Yeah, thanks. So the overview is there's a bit of structure to the beginning that you can certainly ask questions, but it might be better unless you're confused about something to kind of withhold them until we kind of just do the general slideshow. Because then it's going to be more of a free-for-all, pictures, kind of case study, discussion, your guys' questions and stuff like that. All right, again, I've mentioned my background there. This is sort of a repeat of it. And here are the pictures. I think this picture in the top right that's up in Cecil County. It was an emergency bridge inspection, and all that white stuff is ice, and that's me going in to do the underwater inspection of that. But I've transitioned away from underwater inspections, and now it's almost all residential and light commercial. All right, so here we go. We're jumping into this. Houses aren't supposed to shift or move. That's what the structure is intended. It might sound sort of obvious. In some cases, I think it's not. People think, oh, it's a structure, it's a crack. The point is that the house is supposed to be stable and not move under the forces acting on it. Wind, gravity, the weight of the structure, snow, all those things. It's not supposed to move. A little bit of movement is okay, though. Not in all structures, but in residential structures, wood-built structures, it's okay. And if you see these two pictures, you can see a difference in movement. The left picture, you can see the roof is sagging considerably. The right, it's actually sagging a little bit. This is the deal. The left one, I'm telling you, needs some repairs. The right one is probably, in a house like that, is common and it's a safe condition to monitor, but it could evolve into something more significant. But the idea is nothing should shift or move. Okay, sometimes the movement is obvious, like I have that house again.
Recording in progress.
I'm getting some feedback. Anybody else? Can you hear me?
Yep, I fixed it.
Okay, all right. Sorry. So you have the sagging roof on the left. The right one, that's a bulging or bowing foundation wall. I can stick my hand. I got a picture later in it. Sometimes it's obvious and you know you have a problem. Cracks, which is kind of the centerpiece of this discussion, they can point to less obvious signs of movement. And so anytime you see a crack, that says that something has moved. Sometimes, if you look at it from a different perspective, like that bowing wall that I just showed, maybe if you just had a smaller crack, if you sight down the wall, sometimes you can see it's bulging and you can see the movement. but the crack indicates there's been some movement. But that's all it really tells you. I mean, you can glean a little bit of information about a crack by looking at it. For example, the crack on the left here in the drywall, it's a straight vertical crack. That's probably just at a joint of drywall and not necessarily structural movement. The one on the right, that's at the corner of a foundation. You have a step crack. That's usually some settlement. But the question is how much? Something has moved when you see a crack. We want to know as an engineer how much it moves to give the best possible advice. I like this picture because you see these diagonal cracks and it's exaggerated the movement. But if that crack is a lot smaller, that is an early sign of what could come. And that's why cracks are very important. But the most important aspect of it is understanding how much it has moved. And so to understand cracks, you need to measure, and that will help you understand the structure. So there's a couple different ways you can measure the house to understand it better. The one on the left, this is a laser level, that little box there, and you can see the green line that's projected, and you can see the distance between the green line and the floor is pretty consistent all the way around. That shows that your floor is level. So that's like sinking or settlement. That's showing that that's a really good sign. And actually, you can even see the far end of the house. If you look into the far bedroom with the door open, you can see that the line is at a similar elevation, meaning that there hasn't been a lot of downward movement in it. Conversely, you can check for horizontal movement, which is a vertical measurement. I know that can be confusing. You measure vertically to see how much something moved horizontally. Kind of odd. But using a 4-foot level, we can measure a wall to see how much it may be bulging or bowing if you see a crack. So those are the kind of two main ways that you can measure something to understand really what's going on with the structure. All right, so visual structural assessments are about 75% reliable. That is just if you're simply looking at a crack and trying to interpret them, like I was saying in the previous example, the vertical drywall crack is probably not structural movement and not measuring. 75% of the time, if you know what you're looking at, you're going to be right. But sometimes if you measure, you're going to be like, what's going on there? So, looking for cracks, you can get a lot of information, but cracks with measurements are a lot better. All right. Small cracks, this is why, this is going to get into the meat of like the whole process that I've developed. Small cracks normally mean small movement. Large cracks normally mean large movement. So when people, engineers, home inspectors, whoever sees a small crack, they're usually like, this is a minor concern, monitor this or whatever. If you see a big crack, usually they say get an engineer. The deal is that's not always the case. So you see these two pictures on the left, it's an angular crack. It's not really too big. The one on the right, you've got some pretty ugly cracks. You can see them going into the next room in a similar pattern. On the back side of both these doors, I'll tell you, they're a similar crack that looked pretty ugly. The one on the left was a house with real big structural issues. And that was one of the very few indicators visually of what was going on. The one on the right with those ugly cracks, really there's no issue with that. That had been sort of damaged. The house had not really moved in a problematic way. And the case on the right, my theory is that somebody overloaded the attic above that area because the floors were perfectly level, so things did not sink. And it put pressure on that wall, caused some cracks. They had removed the weight, and so there were these remnant cracks, which looked pretty bad, but were meaningless other than cosmetic.
So nothing needed to be done with the one on the right?
Nothing structural. Everything was square, plumb. Something had caused stress to this area. There was an area that somebody had put a lot of planking in the attic. It wasn't full at the time they had moved out, but it looked like they had set up that area for storage. That's my best guess because there's no other, everything was perfectly level, square, plumb, and everything. The one on the left had had like 4 inches of floor settlement in that area.
Wow.
Which was always surprising with a crack like that. I mean, that's a long crack, but it wasn't very big. All right, so the best way to do it is visual assessments with measurements. They're nearly bulletproof in understanding the structure, and it can even uncover problems that you can't see because you can have, let's say, hatched cracks in a house, like they've renovated, painted, everything like that. But if the floor has settled in a problematic way, that's hard to hide. And so by doing measurements, you can see that, oh, there's a condition there which exists and it has been obscured. And cleaning and filling cracks isn't always malicious. Oftentimes it's just a practice of the industry. But it can hamstring an inspector who's trying to help a buyer client understand what may be going on with the house. So here I am that's me, taking a measurement. What's interesting about this, and you have to look closely, is in this particular house, the green line that's a perfectly horizontal line. But if you look at the distance at the bottom right blue arrow, it's actually at the top of the shoe molding. That shoe molding is about 3.5 inches high. That laser was set at 1.5 inches. So right there, it's 2 inches lower than what my reference point, which you can't see where the laser is. You can see that farther away up here, the green line is higher. That means the floor is lower. And if you look in the far end of the house, it's hard to see, but the green line is even higher, meaning the floor is even lower there. So the trend is that whole end of the house was sinking, basically. That's the value of taking these measurements. You can get a lot of information in just a couple minutes, but I'm going to explain to you why kind of doing full house measurements have benefits. But again, distinguishing the nature of a crack, the best tool is taking measurements. All right. So what the heck is going on with the house structure? The picture on the left is kind of like ignore the writing. It's very confusing at the top. So that's sort of like how a house floor is typically framed. You have a front foundation wall. You might have a beam running through a crawl space or a basement, and then you have a back foundation wall, and then your joists sit on top of that. And that creates like two platforms, a front platform, like a span, and a back one. Over to the right, here's the mechanisms of movement that are most common and can be concerning if it's moved enough. The top one shows that the joist, I call it failing. I have an extreme case here. A lot of settlement. That means there's a lot of weight pushing down on the joists, and you get this sort of sagging effect over each of the spans. Do people understand what that is showing? That's a cross section of the house. And so this is your middle beam, the middle area, back of the foundation, say the front of the foundation. And so these are wood joists that are sagging. A little bit of this is in just about every house because wood bends under weight. And that's a normal condition, but sometimes it's too much. And the way you know is you can measure.
Okay, hang on.
Yep.
Just 1 second. Any questions on that? Are you getting what Greg is saying about the structure of this? That we're seeing the joists and the beams? Okay, if you have questions, put them in the chat. Or Greg, did you just come off mute, Greg?
No, I'm here.
Or no, I'm sorry, Greg Fisk, did you have a question? Okay, just want to make sure, because there are a lot of people on here. If you come off mute and I don't see you, what I'd recommend is use your mechanical electronic hand, raise your hand if you have a question, or put your question in the chat and we'll get that. I just want to make sure everyone's got this, because yes, Greg, you're going fast, but this is important as a base to get it, because this is what, when we're doing measurements, part of this is you're seeing this.
Exactly.
I mean, this is what's being hidden by all the furniture and all the other stuff that they've got there that you just don't even notice sometimes.
Right. These are the bones that you're not seeing of the house typically. And so whenever you put weight on the floor structure, and I'm looking at the very top right here, the wood bends down. Your decking, your wood structure bends down. And that creates a little bit of floor irregularity, but it can cause cracks to things that sit on that wall. Doors can get a little bit out of square. You can get a little bit of cracks and stresses. Some of this is completely normal. It's actually anticipated. And the older a house you tend to have more of this going on. But the best way to understand it is to measure, like, how many inches down has it gone.
And we do have a question, Greg.
Okay, go ahead.
From Kay.
Just to be clear, this is as if we're standing in the basement or looking under the foundation. You're not going to really see this from the living level floor other than the results of it, which would be put a marble and it rolls or whatever.
Yeah, exactly. If it's an unfinished basement, you would probably see the top, but you're not going to see that exaggerated deflection, even if it's a couple inches usually. It's hard to see. There's just too much going on. There's mechanicals, there's plumbing and stuff. And it's hard to get a good line of sight. But this image, these three in the right side, it's as if you're looking, can you see my mouse pointer? I could probably make it bigger. If you're looking from the left side of the drawing on the left. And so you're looking, here is one support here in the middle, and one support in the on the other end, and that's sort of the cross section that I'm showing. Hopefully that helps. This is what you might see in a basement if it's unfinished. You wouldn't see, like, this is really you wouldn't really see your foundation areas here. But if your foundation sinks on one side of the house, then the floor slopes towards the exterior wall. And so you might have foundation cracks if you have a lot of floor slope. But that's what you can measure and see. Why is the house all sloping towards one exterior wall? It's usually because the foundation is sunk. And this can mitigate concerns about a lot of cracks. Yeah, wow, why there's a lot of cracks over on the side of the house. You take a quick measurement and you see that it's an inch off, maybe an inch and a half. That's kind of expected. Immediately you can be like, okay, let's calm down. This isn't really a big issue. But if you take the same measurement and it's 3 or 4 inches lower there, that raises some legit concern. And the next common condition would be if the middle support sinks somehow, you get this sort of bowl shape in the house. You get this cupping towards the middle of the house. And a lot of times you have the same thing on the top floor. I call it sort of a bowl. It's also, there's different terms to describe that effect, but I think the bowl everybody can visualize. But this is the most technical slide here, but it is kind of important to understand. You don't really see this movement. You might see the symptom or feel it even walking, unless it's severe, but you might see the symptoms, which are usually cracks or door issues, window issues.
So Greg, really quick question. If you have broken or bent joists, can you leave them alone, or does something have to be done?
It just depends on how much it is moved. And I would say if it's just the joist bending or sagging, that's pretty simple to fix. But it can cause a lot of ugly conditions in the house. Even if those joists have sagged 2.5 inches, that creates a lot of odd conditions in the house. But reinforcing that isn't usually a big project. You just sister the joist beneath that in that area so it doesn't bend as much. So you mitigate the condition. At the same time, you can push the joists up a bit and reinforce them. And we're talking, in most cases, $5,000 to $10,000 repair whenever it's moved quite a bit. That's usually the best case scenario. If the foundation moves, it would be typically more costly. But if it's a joist issue, which is probably the most common, because sometimes there's contributing factors too to joist movement, which is plumbers might have notched or cut the structure some incorrectly. You've probably seen that on inspection reports. That can weaken the joists. Insect damage can do it too, which weakens the wood. It deflects more. It creates some symptoms, and sistering or reinforcing the joists, kind of like a splint, is normally the answer. So sorry, one more technical one. So this is an actual floor plan of a house. And there's all these little numbers in there, like -2 1/4, -2, -1.5. This is 0. So these are actually measurements of a house and how different the floor elevations are. So -2 means it's 2 inches lower than the reference point. So wherever they started from was 0, then there's actually 2 inches lower in the middle of the house. I don't remember how old this house is. That's starting to create some conditions, I would bet, in the house that people are noticing a bit of floor irregularity. The stairs might be a little slanted. The doors might not work correctly. If this is a new house, that's 2 inches of floor deflection. Raises a lot of questions. If this is a 50-year-old house, good luck finding one that doesn't have that. But that doesn't mean that a buyer isn't well served to know this. And it's not wrong to consider reinforcing that, because that's just going to get worse. And at what point are you going to do something about it? It's not unsafe at 2 inches, but it's the structure is feeling the effect of age. But this is using the laser or those different techniques. Mapping this is super useful in understanding the house structure. So this is floor elevations, like a contour map, like if you're hiking and you see your trail map and you see those tight lines and you're like, oh shit, there's a big hill I have to climb. That's the vertical movement. The other one that you're concerned about a house is horizontal movement, and a real common one is a brick wall that has shifted. This is an issue with a lot of Baltimore row houses, some DC row houses that are 100 years old. The wall starts to bulge or move. You can take measurements of that similarly, and it will create cracks, but you don't know how big a deal the cracks are in most cases until you measure. So you can hang a line down. This red line in the middle picture is suggesting hanging a string with a weight. And you can go out a window. So if you look at the left picture, I use a yellow line. Imagine me sticking my head out that window, or Rachel hanging a string with the weight down. And then you can take a measurement lower to see how far the wall might be bulging out. And over on the right side, you can see kind of, that's a pretty extreme case. That wall was bulging, looking at that tape, maybe 6 inches. That's a lot of movement right there. That would be a big concern if the wall is bulging 6 inches. But
it's
again,
kind of
this
neat
isn't.
though. It's kind of neat though, Greg, because and by the way, everyone, I have permission to interrupt Greg to slow him down. And Corner House, I'm going to call on you next, but it's kind of fun for me to see this because it was really neat after I did this training with Greg and went through some properties with him. I did this, and the very first property I think I did, or one of the first ones, had like 4 inches right there that it was bulging. And I was like, come on, really? This is an uncommon amount. And here we are with this big bulge on my first one. Okay, so a corner house. Go ahead.
Sorry.
Kareem, go ahead.
Yeah, sorry. So yeah, I just found out yesterday that I didn't even notice one of my listings in the city, there's a 2-story crack in the middle of the unit on the inside. With something
In the brick? Is it in the brick?
Yeah.
So it's exposed brick on the inside. They did that because it looked good.
Yeah.
And it's an interior row house?
Yes. I'm wondering, are we going to find sort of a bulging of any sort if we measure? Is that like likely with like a 2-story crack interior?
I would say there's probably some. You're definitely in a gray area. I don't think it's. Measurements tell you that's it. But I would say, without measurements, you're in at least a gray area of an issue, meaning it might be something that could be monitored. It could be a bigger issue to have a 2-story crack. But the way you know is you measure the floors and then vertical, and see how much it is.
Okay.
But if you see that it's off or you feel it's off, usually you're at least in a gray area, meaning, okay, you really need to get those measurements. But people have different skills as far as being able to cite things out of plumb. A lot of people, believe it or not, if it's off by like 1 degree, then if you stop and you take a breath and you look at something vertical, if it's 1 degree out of plumb, most people will suspect something's off 2 degrees. They're like, that ain't straight. It's pretty amazing, the human eye. But floors are harder because you don't get the same perspective as you do with a vertical. So the other thing, so I would recommend measurements for that property for sure. So here's that horrible bowing wall. You can do the same thing with a bowing foundation wall, and a horizontal crack normally indicates a bulge in a masonry wall. And you can see my string hanging down, and you can take a measurement to see how much it moves. The measurement gives you the most information. Okay, so I want to get to, there we go. I rushed through that. I did take about 20 minutes. Sorry it was fast, but the thrust of this is really talking points. Before we move on, anybody have any basic technical questions about the idea of cracks tell you? Does something move? Measurements really, really help like solidify what's going on. Because sometimes a small crack can be in a house with a lot of movement. And sometimes a really big crack is in a house with not so much movement. So any quick questions here before we jump into some fun pictures and talking points?
Kay has a question for you.
So I've sold a couple row houses in Baltimore, and they almost all have slanted floors. I mean, they're way over 100 years old. And so once you see that more than just one time out of many, then you go, well, Baltimore, 1900 home, et cetera. But how would you know if that's really an issue? I mean, there were home inspections, blah, blah, blah. But
You have to measure.
I just kind of lay it off to 100-plus-year-old homes.
Yeah, and some 100-year-old homes have 1.5 inches or 2 inches of floor differential. That's the difference between the highs and the lows. And some have 5 inches, and there's a world of difference between the two. Let me say something interesting, or I'm hoping it's interesting, about row homes generally don't have an intermediate support. And so the joists just span the width. So you don't have the right half there. You don't have this stuff. You just have a single span. And so you're definitely going to get some sagging in a 100-year row home where those joists are feeling the weight of all the furniture that's been there for 100 years. But there's a distinct difference in a row home between, or any house, but especially a Baltimore row home. If the low point is towards the middle of the room, like from right to left towards the middle, or if it's sloping towards one of your side brick walls. And I can have a whole presentation on Baltimore row homes and the difference and what to look for and stuff like that. So, but the measurements are
that'll be the
important.
next class then. That'll be the next one.
All right. So, like, look at this laser here. So this is just across a single door in a room. That laser is perfectly horizontal. I know the angle doesn't look like it. The floor is off here. The green line is truly level. If the floor is like the green line, it would be like a surgical perfect plane that you walk on. The floor is dramatically different. And so the deal is anybody would notice that floor is off a bit. And people go, it's an old house. I'm telling you, this raises a lot of questions about the house. That severity over that short distance. I mean, that's like 1 inch over 2 feet and maybe 2 inches over 4 feet. You got to look at not just that area, but the house to see how big an issue that is. But most people would be like, oh yeah, the floors are off. But it's just a question of how much. I'm going to keep going through these. If anybody, I've got about 20, 25 pictures. And we can come back to them. But if anybody has a question about, if they don't understand it, stop me.
Hey, Stephanie, did you have a question? Okay, I'm just going to put you on mute. I just thought you might have that you might have come off because you had a question.
Sorry, my bad.
No worries. I'm glad you got on. I didn't realize some people had a problem with a password, like it was requiring that. How do you deal with? So I'm glad you're here. How do you deal with historical buildings with stacked stone foundations? And then Kareem, who someone said is in the witness protection program, which is why his face is so dark there. He says, so everything is scary. Gotcha. LOL. So you've got how do you deal with the historical buildings with stacked stone foundations? And then after that, we'll address Cody's question. And Cody has actually had a property with a buyer that had measurements. We did measurements and did an ASA on it. So, we'll get to that too.
Okay, so stacked stone foundations, one issue with them is that they have mortar between the stone, and that mortar can deteriorate, and so the stones can start shifting, and that can be a mechanism for structural movement. And because that mortar, which is like the glue between brick or concrete cinder blocks or field stone foundations, once that's gone, the glue is gone, things can start to shift and move. And so you definitely want to look for that. And as a home inspector, that would be an indicator that, you can learn a lot by that. But the one challenge is that fieldstone foundations are very irregular from the side. So getting a vertical measurement, if they start shifting, is kind of hard because the stones, you don't have a perfectly, like a brick wall that's vertical, you can get a great vertical measurement. But with fieldstone foundations, you can't get as good a measurement. So while I'm touting measurements, they're glorious, I'm telling you. Sometimes you got to rely on experience and just using your eye and seeing how much something may have shifted. But I think fieldstone foundations overall are a great foundation. They perform very well. but sometimes that mortar deteriorates. And if you neglect that, which many people do, that it's not a very sexy thing to spend money on, is jamming mortar into your foundation, you can have really big foundation issues. This next picture is actually a super common condition in, let's say, 1970s, 1980s townhouses. And that's in the master bedroom. You get these cracks where these red arrows are emanating from doorways. And those angular cracks indicate movement, as I told you. Angular cracks, especially vertical or horizontal cracks in drywall, usually is not movement related. That's usually bad drywall work. But if you sight the top of that door frame, whenever you see a crack like that, you might see that it's not level. That is further indication of the bigger concern, which is the movement. How much has it moved? But really, to get the best answer is you shoot the laser from like the behind me where you're standing in the picture, like where the front of the house is, in this area to see how low the floor is there. Because if the floor sinks there, it causes both of those door frames to drop, and then you get those angular cracks. Super common condition, and I would say it's super common that the cracks look bad, and it's nothing you really need to fix, but there's some ugly cracks. But you measure, because 1.5 inches of floor slope in this area, meaning the floor drops here 1.5 inches, can cause some pretty bad cracks. That's not severe movement. That's something that's fully safe to monitor. But the same cracks can exist and it's 3 inches lower. But usually if it's 3 inches lower, you would see furniture might be shimmed, meaning they put little blocks under the feet of furniture. There's other things you can look for to see movement, but this laser and this technique is super quick and easy. I'm sure you guys have seen this condition before.
Yeah, and so that's an interesting thing to bring up. Look for shims underneath or unlevel furniture, and just seeing that people have sellers have tried to, or buyers, that they have tried to level it from underneath. And that, I mean, it's a condition in my house where we've got shims on something because it was my floors are uneven and there's nothing going on in that area. What exactly is strapping?
Strapping is, in regard to residential structures, is where you put metal, thin metal strips between two different structural components to kind of tie them together. So it's a piece of metal that you nail on both faces to connect things together. It's used a lot more, and I'll tell you why. Because whenever you start taking out a lot of walls in a structure, you actually weaken it from like wind loads. Like if you have a box and you have a lot of walls or perpendicular things in it, that box is stiffer. But if you take everything out from the mid and you just have a box frame, it's easy to tip over. And so whenever people like these new houses with these big open floor plans, or people who just think they're taking out a couple walls in an older house, it's really not supposed to take out too many walls in an old house that doesn't have strapping, because it can be vulnerable to, I mean, it's called racking or leaning, and you don't want that to happen to your house.
So I'm sorry, Greg. So you're saying that like they are getting like metal pins, like metal rods, and securing the box?
Yeah. There's metal ties. Walls can serve that purpose to stiffen it. Like if you just have like the frame, like you draw a 3-dimensional box, you know what I mean? And you just see the outline of that. If that is your square, like a dice, but without the side walls, you just have the edges. And it's not very strong. You can take it out of shape. I mean, if you build a shed, before you put up your outside paneling on like a small shed, you can push it over and topple it. As soon as you put the plywood on the outside faces, it's much stiffer. It's much more resistant to pushing it over. And so whenever you have, and the bigger the house is, like garages that have no like freestanding garages or barns, especially old ones, those things are not very square because they're susceptible. They're a big space without a lot of cross members. But if you put a diagonal like tie, like a metal rod, that can make something much stiffer. I don't have a drawing of this here, and I can send something out because I got some kind of cool examples of it.
Okay.
But taking out walls, it's a problem. New houses are built that don't have many interior walls have a lot of that stuff in place. And a shear wall is a term I'm going to drop here. A shear wall is a wall that's specifically designed to prevent a house without many walls. It's an extra strong wall, usually on the inside, to prevent it from pushing over in heavy wind. So this crack here is, in my eyes, without taking measurements, is a little concerning. It's a large, long crack. I would never, I would say, in the absence of, if somebody vetted this house really well, went above, below, without taking measurements, I would say it's probably safe to monitor. I think a crack like this would dramatically benefit from a measurement to understand what's going on. It's a diagonal crack. It's not very big. I mean, like gap in it isn't very much. It's thin, like maybe a credit card width, but it's long, and you can even see maybe it's been patched previously.
So when you're
question, if you
saying
don't mind.
monitoring, you're saying you move in there and you go and just every time you change the batteries in your smoke detector, you look at that and see if it has changed. Or like take a picture of it so you've got a record of it and then see if it's changed every 6 months or so?
Yes, but looking at related nearby areas too to see if new cracks appeared nearby. The
Okay,
best way to monitor is to measure it, figure out how, like mainly how low the floor is would be like one measurement, and then remeasure that in 6 months or a year. That can give you heaps of information.
Okay, got it. Now, in this house also, if you were living there, would I don't know, the windows maybe stop being easy to open, or I mean it's older windows anyway, but would that be something, or the doors become harder, they start binding? Are those things to watch for?
For sure. That's what I mean by kind of related areas. The more related conditions, like negative adverse conditions that are nearby, that is steering me one way or the other, like how big a deal is it or how little. But I also would look for general squareness of that window opening. That's more important than the function, because it might not function because it wasn't installed right, or it's humid and it's swelling. If that square that the window's framed in is becoming, what do you call it, parallelogram, whatever, out of square, then that is what you really is more important thing to look for nearby. And same with the nearby door. Is the top of that door opening level, or is it look square? Has the door been cut to fit that space better? These things help inform me about the nature of the condition.
Okay, so also looking at then, is the top of the door square with the line of where the ceiling meets the wall?
Exactly.
Okay, so looking for another vertical or another horizontal or vertical place and seeing and just comparing.
So whenever I do a structural inspection, while I am looking at square and plumb of everything more than I'm looking for cracks, to be honest. I mean, certainly I'm going to see cracks, but like tiny cracks, I just don't really spend much attention to. I'm looking that the window looks like a rectangle. The door looks like the door opening looks like a rectangle. If I see a wall, do I see bulging in it? From the outside, I'm looking at the house. Everything is square and plumb. And some people like think that I've like short circuited because I'm staring at like the side of the house and not moving. And it becomes funny. I'm like, I'm looking at something here, like there's this dead silence. I'm like, I don't think that's straight.
Yeah, it's funny because that's one of the first things that I teach investors is to step back, go across the street and look for those things. Just look at those things. Just stare at it. We have a question from Elliot. Go ahead, Elliot.
Hey, Greg.
Hi.
So asking this because a lot of agents are, they do a lot of houses in Baltimore and DC, like you said, that are over 100, 120 years old. So you're starting to touch on the time aspect of these cracks. So what would you say to a buyer or an agent who's showing a house and maybe there's a 2 or 3 inch differential in the floor, no other signs of horizontal or shear cracking or step cracking, and it's 120 years old, maybe it settled in the first 20 or 30 years and it hasn't moved since, so it's done settling. So to not scare a buyer away, what do you tell them in that situation?
Okay, so first off, I think 2 or 3 is a great example to tell a lot. 2 inches, even in a 100-year-old house, is a defect in that it's introducing some problematic conditions. I mean, it's not unsafe or anything like that, but a lot of people, like, we're talking like you set your kitchen table up or your dining room table, and it's not sitting on all the legs. And, or your soup bowl, if you fill up your soup bowl a lot, you start noticing that, like, it's kind of spilling off. It's a shallow soup bowl, it's spilling off, and the doors aren't closing. That's not necessarily gonna change somebody's life a lot, but there's plenty of houses that have less of that and more of that are. There's a wide range of these conditions in a 120-year-old house. I would say 2 inches is the beginning where it introduces some problems, but that's not a big issue. But at 2 inches, maybe if you keep that house for 10 or 20 years, it might become 3 inches and you might have to spend some money. So understanding your starting point has a lot of value. 3 inches, and it also depends on where that low point is. If it's in the floor structure, meaning in the middle of the house where the floor is sagging, that is much easier to fix and less of a concern for that reason than if your foundation has sunk 3 inches.
Right.
Because you can, if your foundation sinks like that, you got to get out of your house. If it's just the floor framing, there's many ways that you can address that if you choose to at a much more modest cost. So 2 inches in a 100-year-old house, I mean, that's pretty much par for the course. But let's say the 2 inches is in a very distinct area, like a bathroom. That's a common case because the bathroom may have had a past issue with water leaking, or a plumber may have cut or notched joists to run drain pipes. Keeping that on, knowing that that's the low point, 2 inches, you don't really need to do anything about. But if they're buying it, understanding like they might need to put some invest some money in that area, rather than it just be this vague thing that, like, yeah, the house is old, it's off. Well, really, this is the area that really matters. Right here, it's a bathroom. That's manageable. You might be planning on renovating the bathroom. When you renovate the bathroom, don't just spend 20 grand and don't fix that at that time. But at 3 inches, I would say that you're at, even at a 100-year-old house, there's a lot to think about with 3 inches. Certainly, you're on the radar for repairs. And I don't know why people are willing to reinvest in many, many aspects of a house as it ages to 100 years, meaning you've replaced the roof how many times? It's been, a lot of money has been spending on it, and people are reluctant to spend 5 or 10. I understand why you'd be reluctant to spend 50, but to do things to shore it up. I mean, as our bodies age, and you get hip replacements and knee replacements, you don't just ignore that and you try not to and accept, hey, I just got bad knees. A house is kind of the same way. You might want to reinvest in the structure, but it's a balance for a lot of these. Like, how bad are the conditions and how much does it cost?
Right. So a home inspection isn't always going to be able to dictate if there's an ongoing issue. It's most of the time, again, especially if you can't see any, if you can't see any shear cracks or anything like that, the inspection is just going to discover that, hey, there was a problem. It's still in this condition. It doesn't necessarily mean that the problem is continuing. You might want to fix it. I'm just trying to not scare away buyers. Having the buyers understand there is an element of, we're not sure, and this could be done settling or cracking or whatever the case. We're just using our best guess at this point.
Yeah, what I would say, though, in the absence of evidence of repairs, there's no reason to think that the underlying condition has been fixed. Meaning, like, let's say in an old row house, the floors are off by 3 inches. I would say a likely cause of that is either a plumber or an insect damage if it's 3 inches. If you are a buyer and you're aware of that, it might be perfectly safe, and they might be happy with that. But knowing that there is a defect there, and it's that kind of condition oftentimes is $5,000 or $10,000, you can negotiate for that. It's much worse to find out later that there was something that was very measurable, quantifiable, and could have informed them than finding out later. But it also helps, like, narrow down any kind of concern to a specific area rather than being sort of this amorphous thing, like it's an old house, it's got some quirks and some weirdness.
So really, Greg, we don't want to scare the buyers because that we want to make sure that they understand, and we want to manage their expectations that any house could have any of these conditions, and we're going to measure it, and you just need to be aware of it. So if you're doing work, you need to pay attention, but there's also do the measurements, get what this is, and see if there's something, like, pay attention to it. But every structure is different. So, and every location where the measurements are taken, they could be lower in different locations. So it's really is very specific to the property.
Oh, absolutely, it's specific to the property. And let me add too that I think good assessment with measurements is going to diminish concerns because you understand it better. And you can say, like, this is the condition, this is what you're up against. And most fear is uncertainty and not knowing and not understanding the structure or what's kind of going on. Yeah, I know I got these cracks, but as soon as you quantify it, you're much better off. And then you have a plan too. A measurement is so much more repeatable than looking at a crack and seeing if that crack has changed. A measurement is very scientific. And so they can have a plan, like, okay, they know that there's been a bit of movement. It's an old house, no drama here. Let's take a measurement after you buy it and see. And if you might prove that it's stable then. That's huge. And small changes, all of this can be managed. But most structural issues, are like $5,000 to $10,000. And if a buyer is buying a 100-year-old house and doesn't understand that, I think that there's a risk of real disappointment and an upset person after they go in and do that. And it's totally avoidable, is that kind of thing. Not having that kind of surprise. All right.
And that really is part of the purpose of the advanced structural assessment that home inspectors can do, which is doing the measurements and then getting them to you, and then you're able to, and videos and pictures, and you're able to actually then give some insight specifically to that property. Right?
Yes. And I guess a huge thing that I've neglected saying is, in so many cases, like if you just take 1,000 houses and you just do measurements, more often than not, what you're proving is that the house is sound. That is the best way to prove it's sound. It's not by not seeing cracks, because cracks can be repaired. The cracks that show the movement could be underground. They could be behind walls. You might not see that. The best way to prove it is by taking the measurements. In a house that looks very suspect, you take the measurements, you're proving that there's not a big deal here. So it's not necessarily about sniffing out issues. It will, and it is, follow me around for a while. You'll go at a house that looks perfectly squeaky clean, and you take a measurement, and you're like, wow, nobody would have known this. But more favorably, as far as the business aspect of it, is that there can be just a bunch of cracks. Somebody's feeling uneasy. If you do take the measurements, chances are they're going to give you the information to be like, okay, this isn't as big a deal as it looks. That's typically what happens, but you just don't know till you measure. All right, let me hit a few slides here because I just want to do these drywall ones for sure.
Yeah, and you said you can stay on for a little bit afterwards.
Oh yeah, so I can stay all day.
Okay. Okay.
I have to go to the bathroom at some point. But. All right, drywall cracks. And I'm going to leave plaster out for a second. Plaster's another topic, but drywall cracks create a lot of drama. I would say it's probably 40% of my business is looking at drywall cracks and making an assessment. Looking at cracks, let me just tell you about this. If you're just seeing horizontal or vertical cracks in drywall, it's almost always at a joint between drywall. If you look at the picture here in the bottom right, all of those white lines where two pieces of drywall are meeting. So basically there's a crack straight through the wall there, and drywall work is about hiding that. And sometimes it's not done very well. And so that joint appears as like a crack. So, and it can scare the hell out of people, this condition, because you can have a lot of bad drywall work and you have all of these cracks. But in the absence of diagonal cracks, it's probably drywall work. You guys following me with that picture down there? This is kind of a very useful point, I think, about drywall cracks, because you have all these joints and horizontal or just straight horizontal or vertical. But if the house does start shifting, the first place it's going to aggravate are those joints, because they're like naturally weak areas. But it's a narrow window, I think, between a house that starts shifting and it aggravates those, and they really start appearing, and you have no diagonal cracks. And so if you have both, there's probably been some structural movement. If you only have vertical or horizontal, then it's probably just drywall. In a ceiling, whenever you have a straight crack, you do want to measure the floor above. That could just be bad drywall work, but it doesn't take much pressure. If the floor above starts to deflect downwards, that's going to put a crack. Drywall can only bend so much before it splits. So ceiling cracks that are straight or a little different, you probably want to get a measurement above or try to assess the floor to see if it's sagging down. All right, vertical, these are also same thing. I showed you the horizontal about the joints. The one on the left really looks like a drywall joint. This one does too. The one on the right, I'm getting a little sense like that might be something different going on. It looks like the crack is aggravated in kind of an odd way. If I'm not getting measurements and somebody sends me these pictures, I'd say the first two, if that's all you're seeing, that's just drywall work. The third one, I'd say you really would benefit from getting some measurements there just to be safe. And again, like some basic measurements of that area are pretty simple. I'm an advocate for like measuring the whole house to really get the best understanding. But a measurement there, meaning you get about 10 or 15 feet away and you see how much lower the floor is there relative to a nearby point. If you see cracks, usually in the middle of a house on a second floor, the house sounds very specific, but a house built, let's say, after 1970, this is probably something called truss uplift. This is a pretty specialized condition that can look. I have it in my house, and I was tested. I knew what it was. I bought this house in 2014. I moved in the first winter. All of a sudden, I started seeing stuff a lot worse than that, and I knew that this was a possibility. I'm like, this is truss uplift, Greg, but I did measure and my floors were level. So what happens is the framing in the roof contracts. And as it contracts because of temperature, it can create stresses. But you can discount that that's a settlement or foundation issue by measuring the floor, and the floor should be level beneath that, because that same condition looks like the floor might have dropped where that wall is, because you can see that's called corner bead. I'm going to show you what that is later. It looks like that could have pulled down, but this is a unique case where it actually got lifted up. So corner bead creates almost as much drama as drywall joints. Corner bead are these strips. They're 1 inch. They're usually aluminum or vinyl. And at the corners of drywall, they put it over the corner to hide the ugly, ratty connection or corner of the two pieces of drywall. What happens is at the edge of that piece, that corner bead it's called, that should be taped. You put a piece of tape over it, like drywall tape, and then you spread mud over it. You're feathering those lines into the structure. A lot of times they don't tape it. And so there's where that vinyl is and the drywall is, it can separate. They just tack nail it. And if you get a line 1 inch away from a corner, like a crack, that's corner bead. And that's almost never a structural issue. If you have tons of movement, you might also have that, but that is usually a red herring. That kind of crack, 1 inch, perfectly vertical next to a corner. Or it can be an inside corner too, if you know what I mean. That's an outside corner. An inside corner, if you look at the very bottom right, like below at his wrist, back there, that's an inside corner. You would turn the corner bead the other way. All right. I want somebody to comment on this. Anybody, any brave volunteers? What would you do if you saw that in the house?
Somebody stepped on the floor.
Bingo.
Yeah.
I think that's exactly it. I do look at this on ceilings of the top floor. They had a contractor at some point go up in an attic, usually not that bad. That's pretty obvious. And somebody would be like, that just appeared after the guy was up in the attic fixing something. But that kind of thing, even less so, just sort of a random thing on the ceiling, especially if there's attic above, that's probably just somebody stepped on it and, pushed through, which is actually a very dangerous thing. It's actually the most common claim by home inspectors is putting their foot through the ceiling of an attic. They miss while they're walking because it's precarious up there, and they put their foot down on the insulation and they push into the drywall. All right, we're moving to some brick. This might not be all brick, but I kind of grouped them together. Any drywall questions before we move on?
Yes. What about multiple straight line cracks in the ceiling?
Like parallel?
Yes.
So if it's towards the middle of the ceiling, like if you look up and it's towards the middle of the room, you could have the floor deflecting there, and you're seeing, and if they're spaced 4 feet apart, they're probably at drywall joints. You would probably want to measure above, but if they're parallel and straight, I bet you they didn't tape the joints or something like that. But it's a good idea to measure above or somehow sight, just make sure the ceiling isn't pushing down like, the trampoline effect.
Yeah, they're straight lines, like they look like they're on all the beams, but then like there's one parallel across that meets, the straight lines.
So
Like a
I would
perpendicular
say
one?
Perpendicular, yeah, sorry, perpendicular.
if the spacing is about 4 feet or 8 feet, that's the shape of drywalls come to that size. I mean, it can be cut. I would say it's probably bad drywall work, but you want to try to eliminate to make sure, because if you have bad drywall work or floor movement, it can be an early sign of something like, oh, something's going on there. One other thing, which I do look at a couple times a year, kind of scary, is from like mostly the 70s or 80s, sometimes ceiling drywall is attached with the wrong type of nail. They're like, sometimes a contractor used a smooth shank nail, like a roofing nail, and that drywall, the structure isn't moving, and it's not just a joint issue. The drywall is pulling off, and it can fall, and you can get seriously hurt by that. But that's not a structural issue. It's a rare one where you can get really hurt by your house if the drywall falls off. I mean, a sheet of drywall falls and hits you in the head, you're not going to have, that's not a good day for you. But it's hard to distinguish that. But if that's why some kind of measurement can help. You can also, if you see that, let me add this. If you see a lot of cracks up there on your ceiling, push on the drywall. If there's play, that's not good. That could be a structural issue, or the drywall could be separating from the framing, and it could be coming off. So I would get up on a ladder and push and see if there's any play in it.
Thank you.
So brick cracks. Go ahead.
One last thing. So it is 10 o'clock or 10:01. So if you have to go, totally understand. And what I'll do is I'll get this up on our YouTube channel tomorrow. So if you want to see this and you can't stay on longer to ask questions or see all these cracks, because now we're getting into some even more fun ones. And we have a list of questions that we're trying to get to too, as we go. If you can't do that, I suggest subscribing to our YouTube channel, which is at Lodestar Inspections. And when I upload it, you'll be notified right away so that you'll know it's there. And then you can also share it with team members or clients if you want to, or whatever it is. So I get it if you have to go now, but we're just going to keep going. And Greg is being really generous with his time, said he could stay till like 10:30. So stay on if you want, if you can, and we're happy to have you here. Go ahead, Greg.
Sure. So there's a lot going on in this picture. Hopefully you can see it pretty well. So those cracks are not very wide, maybe 1 or 2 credit card widths. A credit card is about 1/32 of an inch wide. And if you're making some general terms, if you can't get a credit card into it, to me, it almost doesn't even qualify as anything. And you would call it a hairline. But the first measurable size is about 1/32 of an inch, is about the width of a credit card. So these are maybe 1 or 2 credit card widths, which is considered a small crack. But if you look closely at this picture, you can see those cracks have been patched and you can see the crack. That gives you some information that something has changed since it was patched. Whenever you patch it, you shouldn't see the crack. The other thing is if you look sort of in the middle area, you can see the mortar joints are very white in some areas versus a little grayer. I'm kind of circling, kind of where the arrow is, the left arrow. I actually have a left arrow there pointing at it. There's been an additional repair there. So this could have actually, and that doesn't look like that's reopened. So there is some questions here. None of the cracks are concerning, but because there's everything going on here, this is a bit of an elevated concern for me. The way that you can understand it and hopefully find that it's not as bad as it may look is by taking measurements. Do we want to maybe jump to these questions in case people want to go that were posed, that were sent in advance? I could bust through those in a couple
bust
minutes.
through them and I know you have a ton of pictures, so
Yeah.
why don't you see if you can answer them as you're going with like showing pictures? Would that?
Yeah, I don't know if they apply to these, but let me just hit a couple of them. Somebody asked about older homes floor beams that are damaged. All right, so the floor beam, I'm assuming that's probably wood. A lot of old houses have wood beams, and wood tends to deflect or bend more. If it's damaged, I would say the good news is that it's pretty easy to repair. If you can, the cheapest way is, it might look damaged, but if, in any case, whether it's moved a lot or you got insect damage and you want to mitigate that, you can put a post underneath that area. And in the particularly old house, basements aren't usually used for finish. It's an unfinished basement. It's a pretty inexpensive way to address that issue. You just put a column underneath it to stop it from moving. That's the concern, is moving more. The more difficult but still relatively low cost way is you reinforce that beam. And if you don't want the post because you're using your basement for whatever reason, and you don't want that post in the way, then you could reinforce that beam by adding boards on each side. So it's usually pretty cheap and easy to fix. And it is a common issue in older houses, maybe the most common. Like whenever you're on the tier of like, okay, this is a legit concern, because a beam is a major structural component. You don't want to damage major structural component. Individual joists are structural components, but they have less of a role, because if they move, it affects less of the house than a beam. If a beam moves, it affects a lot of the house. All right, another question is, I like this one. It started being very cautious and tactful, and then did exactly what I do. It says, there is a very specific big home builder all over central Maryland known for having really gaping cracks in their foundations. Why would a builder do this, and what are the ramifications to the future homeowner? I like that. I love it. And I even love more than those parentheses that says Ryan Holmes is the builder. I'm unable to hold back by just go ahead and calling it how it is. So thank you for sharing who the builder is. I think that Ryan Holmes is I'm going to add this, is no worse than any other builder. With new homes, whenever you get a bad house, it's usually because the project manager is too busy. They're doing too many things, and they're not providing oversight, because subcontractors aren't great. And a subcontractor needs somebody to tell them, hey, do better. And that's what the project manager's done. But if the subcontractor does bad and the project manager is too busy and not catching it, that's when you get problems. There's no good reason why you should have a crack in your foundation of a new house. But I would say, and the downside about that is the house is so young that you don't, like, you can get some settlement cracks in a house within a year for sure. And you can measure and be like, okay, it's an inch off. Like, I'd be like, okay, that doesn't really matter. But because it's so young, you don't know where that's leading. And a builder's not going to probably do much about it. They might seal it to prevent water infiltration, but they are unlikely to do any kind of repair. And I kind of agree, there's just not enough evidence of movement at that point to mandate it. But usually builders will at least fill a crack. Uneven flooring is another one. We've talked about that. That is the clearest indicator of a potential structural issue. It's all about how uneven it is. Older houses, you expect more unevenness. but that doesn't mean that all unevenness is the same. You can have two old people who have, one has crippling knees and the other doesn't. They're the same age. There's two different conditions. And then you could have a third guy who had a knee problem but got it fixed and is on relatively well functioning knees. I think that's my best analogy for the old house. I don't know if this is all the question posed in the intro email. Oh, yeah. Do we want to the original thing you sent out, Rachel? You want to look at that again?
Yes.
I'm going to do another slide while you look at that.
Yep.
All right. So these cracks, trademark issue. I mean, classic case. This arch at the bottom is a bit weak and it's settling. Those bricks are settling and it's showing the spreading crack at the bottom is bigger at the bottom and smaller at the top. This brick is showing signs of movement. I might conclude in this case that this is safe to monitor, but anybody buying this house should have a good $10,000 on their radar. They might need to spend that to fix this. That's probably, but I would want to measure other areas of the house or look at other areas of the house to make sure there's not something much larger going on with like the soils underneath the house or something like that. All right. Here's another reason why, like, that's a pretty huge crack. It's been filled, painted. If you don't look really closely at the brick, you might not realize that that house is considerable movement. This particular house was about 5 inches off. That's a lot. It was really problematic. But if you did not measure and you don't really feel it, I think most people would have felt it. But it might be just something like it's an old house. The floors are off. But I just think throwing a measurement at it is going to give you a lot more. But that, if you don't walk right up to that area, it looks clear here that that's a big crack, but it wasn't if you just stand and look at the house. So I know this is a brick veneer. The difference being this brick is not holding up the house. It's like siding, vinyl siding. It's an exterior covering. There's oftentimes cracks just in the veneer. And the best way to distinguish whether or not it's limited to the veneer versus the house is to measure the house. If the house is level and you have, I don't care how many cracks in your brick, it can look terrible. You can prove that it's just the veneer. That could still be expensive fixing the veneer, but it's not fundamentally a structural issue.
Greg, someone else brings in iPhone 2 brings in a marble every time they go because not confident with the laser level. So that Bosch laser level is fantastic, and I'll put a link to it in the email I send out.
I think the problem with the marble is that it can move in many houses, and if the velocity that the marble moves is really the way to understand the marble test. If the marble moves quickly, then the slope is more. If it just moves some, it's less. But I think that laser levels you can get now for under $100. I mean, I could show some. I show a lot of my clients. I don't push me coming back and remeasuring. I tell them to spend $100 if I think they should monitor it and remeasure that spot in 6 months or a year. So a laser level is really better than the marble. The marble can actually scare you a lot, I think.
The dogs like the marble. Sorry about the dog barking. Is the roof gonna fall in on me? And it has a finished basement. How do I know if the foundation is okay? Are the other two questions that we didn't address?
All right, sorry. The first one is the roof gonna fall in on me? Well, I'd say no, and I haven't even looked at the house. But if you step away from the house and you look at it from a distance, and if it looks level and square and not like pushing down, just sight it. That gives you tons of information about the stability and soundness of the roof structure. Second to that would be looking up at the ceiling on your top floor and looking for, cracks, and like significant cracks would be it. And the second question you said was?
If it has a finished basement, how do I know that the foundation is okay?
I love that question because guess what my answer is going to be? You got to measure. The measurements can actually uncover hidden conditions. Because a finished basement, you might have a bunch of issues with the main beam, like there could be termite damage and it's hidden. And then the interior cracks of the house, which exist because of that movement, could all be patched and concealed. You can't hide that the floor sinks if you measure. And so by taking a measurement, you can prove that the floors are level. There can't be a big thing going on in the basement that's huge, or you can be like, hey, there's something going on in the basement.
Cool.
So this crack is a common one, which I would say is a red herring. If you got in brick, if you've got this is a door opening, and that dark area is steel. It's called a lintel. Over that opening, there's a piece of steel, like a steel beam, which holds the weight of the brick above. That corrodes over time, and that corrosion, it sits kind of in this area, expands, and it can cause a crack exactly like this that emanates from windows, the top of windows or doors. And if you don't see anything else and it's coming from there, that's what it probably is it's something, just seal the crack and move on. But I've seen them so bad where each window, the crack gets so long it connects with the next window. And so there is a crack that goes almost all the way around the house at a certain height. And that creates a lot of drama for people.
But nothing that needs to be addressed.
No, I think, cleaning the wire brushing the steel and repainting it, and then filling the crack, because the crack can get very ugly if you get moisture and freezing in these things. So it's more of a maintenance item, but not a structural repair.
Great.
This crack immediately raises a ton of questions, I'll just say, for me. Because you can even see that the brick changes slope at the crack. It's going down here. I can see that. This is I would say, is that I'm trying to see if this is a veneer. That might be a veneer. So you would want to make, and I'm saying that because you only see the sides of the bricks. If you see the end of the brick, meaning a smaller square, that means the brick is going away from you, and a structural brick wall is as thick as a brick is long, which is about 8 inches. So if you only see the sides of the brick, it's not structural. And then if you see the ends of some bricks, because they can be different patterns. But I would want to measure the house. That's a veneer. Brick, again, a big thing like this, that should be cited. Whenever you see these stars, these are structural repairs. That brick was bulging, and somebody put these tiebacks. These are rods that go into the house with these stars, which are plates, which hold the bricks from bulging out more. Very common repair. You can actually see it on both sides here around the corner, those stars. So again, this is a Baltimore row house. Same house right here. You just put the laser, you can see, hey, why is the wall not straight? There's some exposed brick. I measured here, but you can't see it very well. I measured kind of here at those bottles. So I copied, and you can see, and so that green line I drew, but it's the same slope as my measurement. You can see the brick's not level there. The brick should not be that off.
So this picture is really cool because it demonstrates what you were just saying about how you can tell if it's a structural brick wall or if it's a brick veneer, because can you point at the
yes, right here in the middle, you can see there's the ends of bricks. Can you see my mouse moving?
Yep.
You can see the end of the brick. What is that called? A stretcher row? I think it's called a stretcher row.
I think so. I can't remember. My grandfather was a stonemason, and it was in Wales, and that was one of the first things he taught me as a little kid. I could identify that as a small child.
That's cool. Wales stretcher row. So that is a structural wall. All right, we're gonna hit a common one that comes up is horizontal cracks in a cinder block, which is also called CMU, which is concrete masonry unit. So cinder block, concrete block, CMU, concrete masonry unit, they're all the same. And they are hollow concrete blocks. You see these. A horizontal crack in this type of wall typically shows that the wall is pushing inward. It's bulging inward. I showed that picture earlier where I could get my hand in the gap. That's an extreme case. And you can't see it. It's not close, but there is a hairline crack in that wall. I measured that wall, and it had moved like 2.5 inches. I was surprised because the crack was small. 2.5 inches needs repairs. And I think I have a picture of a repair for that. This one is more conspicuous. I think you might be able to see that the wall is bulging there, but you don't know how big a deal it is until you measure. Typically, if the wall is bulged in 1.5 inches, that means it needs repairs. If it's 1 inch, something's going on, but you can monitor it. That's just, let me just give you some numbers there. And so that other one at 2.5 inches is quite a bit. Small cracks horizontal, this wall should always be measured to see, because the cracks don't always, that normally is less than an inch of movement, that size cracks, but once in a while it's not. And there's that beautiful one. I stuck my hand through there and got pulled dirt out of the backyard even. I was,
Wow.
yeah. It actually was potentially unsafe to stand there. So it probably wasn't, I'd hate to be the engineer who's telling everybody, hey, this is a big deal. This is really dangerous, and then gets buried underneath block. But I risked it. I risked it for the picture.
Well, thank you.
All right. We're actually pretty close to the end of the pictures. Let me look at a couple more questions. Did you want to read those couple that you had, or were those them about the roof falling in on you?
Yeah, so that's it. Are these just settlement cracks? And what's that crack in the ceiling? I think we did that one. We see this a lot though, what you're showing right here in this poured concrete foundation. Can you address that? And I'll bring up the other questions.
Yeah, so I think this it's a smallish crack. It's very easy to measure in the absence of this additional information. I'd say this is probably nothing. Part of the reason is because the cracks actually they don't join there. But the fact that the right crack is a little bigger at the top and then as you go down suggests that it's opening like this, meaning that the right side might be dropping a bit. But all in all, it's very small. I think most home inspectors they're going to mostly be right, would be say this looks good to monitor. Again, to get and I would agree, but a quick measurement would give you a little more certainty. Maybe not the whole house, but 1 or 2 measurements above to see if the corner on the right side was sinking. But I'm looking at those horizontal lines. Those aren't actually bricks. That is a poured concrete foundation. It looks like brick. Things look pretty level there. I do see this other question here that I want to answer that was sent in the email.
Mm-hmm.
The question is whether I fix cracks in the basement. We don't, and this is hugely important. You don't want an engineer fixing cracks, and you don't want somebody who fixes cracks making an assessment. You keep them separate. A contractor should never come out and do some kind of a recommendation on whether or not repairs are needed or not, because their interest is in selling a repair, and you're going to get a lot of scary, bad, expensive situations. So we don't fix cracks. You don't usually fix a crack like people think. Filling a crack does not fix it structurally. That stops water. You fix a crack structurally, a foundation crack, by getting under the house and stop it from moving. So, anytime somebody wants to put caulk or something in it, that is not a structural repair. That is only water mitigation or cosmetic. Foundation cracks are frequently associated with water damage, meaning the corner of the basement where a downspout was, the downspout at the corner of the house wasn't managed. It dumped water at that corner for years. The soils were weakened, and that corner of the house settles. And oftentimes, that's a very common inspection that I do, is somebody sees cracks, and I'm able, by measurements, to determine that that this is the only area that needs repairs. This 10 feet from the back right corner of the house, because everything else is level, and that corner is 2.5 inches lower. What issues can be caused when a footer in the crawl space is dug out? Probably the worst situations that you can imagine, which is the house sinks. If it's not done right, it's the riskiest probably renovation that can be done to a house if not done correctly. You're digging under the main load-bearing area or near it. Even near it can be risky.
We have a lot of people ask about on home inspections, or when people are looking at houses, they say, okay, well, I love this, but we're going to take out this wall. Is this a load-bearing wall? And so the question with that was, what do you say then to your client? Because we do get that a lot, and I know a lot of agents get that.
All right, so actually determining load-bearing walls can be very tricky, and I think a lot of times they're approached with they are with a more cavalier attitude than I follow. And the reason is because once you know how many houses are built, it's easy to be like, I've been in this like 1985 colonial. I know where the load bearing areas are. I'm looking around and looking where you can. And so I did some assessments based on looking at it and knowing construction stuff like this. And then I went to a couple houses in a short period where there was an assessment done by an engineer or architect, and the people had an issue after, and they wanted another opinion, and they were incorrectly removed, or one was started to be removed and the other had been removed. And what I realized was weird stuff can be done if you don't see the underlying structure. So to assess a load bearing wall with just looking at drywall and not cutting a few holes, I really would never do. I can give you probably a 95% certainty in most cases, but I would never give a letter or approval for removal of a structure of a wall without cutting a couple holes to see what's going on.
So what would you say as a on a home inspection, just looking at it and someone asks you that, or what would you recommend that a realtor says to their client about that when they ask?
You 100% need an engineer to do the assessment, or an architect. A lot of architects don't, but they're technically qualified. You should never have a contractor make that assessment. And if you take it out, you need an engineer to design the beam, because I was at a house yesterday, and they bought the house. They realized that maybe a wall had been removed. I measured, the floor was off. They looked at some pictures and realized this wall was only removed a couple of years before. The floors were an 1.75 inches lower directly over that beam, like it was sagging. That should not happen with a brand new beam, no matter how much weight you have on it. I cut some holes. I investigated. There were no permits. We looked into that. What the contractor did, it was a flush beam, meaning you don't see the beam, it's in the ceiling, or a recessed beam, which is very nice. The beam was put in place. The height of it was the height of the joist, and the width was the width of a 2x4 wall that it was resting on. It needed to be bigger, but they built it because that's what fit easily in the space. I'm quite sure of it. That's not how you design a beam, right? You do it to carry the correct weight. They did it because it fit in nicely where they wanted to put it. Not the end of the world. This was not unsafe. I told them this. And I even told them, it is wrong. It's sagging. But I looked at enough areas that I'm like, you have more movement than you should. It's regrettable because this is a relatively new renovation that was done. But to fix that was probably around 10 grand. And because you have to pull off the drywall and do a bunch of stuff, and it was not an easy thing to fix. They are buying a laser level, and they're going to take some measurements. If it gets worse, they're going to reinforce. But if it seems to hold steady, they're going to be fine. So this is obviously moisture coming in through a crack here. Like, this is kind of neat since you just asked the question about moisture and cracks. Very small cracks here. Typically, I would say almost every home inspector is going to be like, this is minor. I would agree based on just looking at it. Here, what you have, so, this crack, so this is actually, I know it is, this is a concrete block foundation, and this has been surface parged. That's where they spread a layer of mortar, so you don't see the blocks. Because this is on the outside of the house, that's a deck above. It looks very industrial if you can see the blocks. So it's very common that they do a skim coat over the outside. A lot of times cracks are just in that skim coat and they don't go all the way through, but you don't know. You don't see the actual structure. But because this is following the pattern of the brick, I'm betting that the bricks have some cracks in them too. It would be real neat to see the inside, to see if you can see the actual brick. But these cracks appear small. This doesn't look like it was recently parged or patched. It looks like a pretty benign condition. This was a house that had a lot of issues. This is a pretty long crack. It's not huge, but it's actually quite large there. This house, the back of the house had dropped 4 or 5 inches. But that's about the only thing you could see. Once you measure the interior floor, the 3 people were there. I didn't really notice it walking in. I was just walking through the house to the back to look at the crack. Once I measured and walked it a few times, I'm like, wow, this is really walking downhill. But even I, who am pretty attuned to this, didn't really notice that much slope because it was over 20 feet. It had dropped maybe 4.5 inches over 20 feet. All right. We can do questions, but let me just hit my conclusions. The timing is pretty good. So, no cracks in a house normally mean the house is sound. But you don't know for sure without measurements. Small cracks normally mean small issues, but measurements are going to tell you the real story. And large cracks normally mean structural issues, but measurements are going to tell you the real story. That's it. I think I've beat that over the head a lot. Rachel, what do you got?
I think that's great. And unless we've got questions, I think we're good. I have put the link to that. Oh, and here's all Greg's information too, right on the slide. And I have put the link to the laser level in the chat. And if you have trouble seeing a red line, they have one with a green laser that is much easier to see. And yes, Kay, real estate is location, 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 and foundations are measurements, measurements, measurements. I love it.
Where is that? I want to see that. I didn't see that in the chat.
That is just right before Peter said, thank you, great presentation. So thank you, everybody. If you want another class with other details, more information, we can do another one January or February, I think is what we were looking at. So let us know. And mahalo nui loa to you too, Kay. We're glad you all were here. Sorry about the passcode issue. Not sure what the heck happened with that, but it's Zoom and technology. Greg, you had something else to say?
I have one more thing that I forgot to say. All right.
Yes.
So, biggest message here, I think, for buyer agents, whenever you have a buyer, it sounds a bit self-serving, but it is true. Getting somebody like Lodestar to do the inspection, who can do the advanced structural assessment, that's where they take the measurements, is hugely useful. Yes, it increases the cost, but if you look at what you're spending, other than maybe mold testing, there isn't I think taking measurements has more benefit to understanding what's going on. I think mold testing is a super valuable add-on, but I would really seriously consider educating a buyer about the advanced structural assessment. That's where a specially trained home inspector by us takes these additional measurements. They send it to us for review. Second thing is, after the fact, if there's a structural issue, I do still go out on site and I do these assessments. Third thing, this is brand new initiative. This is cutting edge. You're probably the first agents to know about it. We're doing a pilot program where home inspectors that we've trained, instead of doing the full whole house advanced structural assessment, which might take an hour and a half more, they can, if there's a particular concern, they can shoot some video, give us a little bit of information, and we can remotely, within like 24 hours, give some information and a structural opinion about it. I do think that measurements are the best, but the next thing is I understand that some people don't want to spend that up front. They don't want to spend the extra money, and something comes up on the inspection and there's a lot of drama. We can probably take a lot of fear out of it. And so we're doing a pilot program where especially trained inspector sends us the information and we give a pretty rapid response on whether or not we think it's a big deal or not. Sorry, I forgot to say that. That is all I have unless there are questions.
That's great. Cody had a property that where the person ordered it. And I think it was the first time that Cody had heard about it, about the advanced structural assessment. There was a long crack across the front of the house in the cinder block foundation, the CMU. And it was interesting because the buyer was just concerned and it was just something to keep an eye on. There was a lot of homeowner stuff in front of the crack, but we could see it. But it was interesting to be able to go through that and be able to share that with Cody. Cody, I don't know if you're still there in a way that you might be able to share like anything that you got from that.
I'm still here.
Okay, but it took long. and it took longer, like it added some time, but which is why I did that while Derek was doing the inspection. But
Yeah, we had every test going on that day.
yes.
Yeah. No, it's that, and this has been fantastic. So I feel like I'm equipped with a lot more information, because what if I like going around, I'll point out hairlines to people, and then I was told by other inspectors, if you can fit a coin in it, it could potentially be an issue. I like the credit card thing.
Similar.
But yeah, measurements.
Bam, you passed too. So you got
Yeah.
2 people who have passed the class.
Yeah.
All you have to do is say measurements, and you get your diploma.
I think everyone got the message for sure. So thank you. I can't thank you enough, Greg, for taking the time to come and do this. And yeah, we learned so much from each other that this is just, it's fantastic. And all of my inspectors will be trained to be able to do the advanced structural assessments by the end of August. So the training's happening, the final formal training is happening then. We've just been shadowing with Greg, and let me tell you, the guy's got a ton of information. And what's interesting is his wife is a home inspector too. And people were trying to the way this came about was people didn't want her for the home inspections because they wanted Greg because he was the engineer. And he's like, she's a fantastic inspector. How do we make it so that we can actually have her giving me the information? And it was about 10 years of building this to get it together and get the information so that he would have the information he needed to be able to provide his word and signature as a professional engineer, giving some recommendations or saying if something needs to be done or it's stable, which is, of course, in most cases, it's just providing peace of mind. Everything's fine. Did I recreate that right, Greg? Because I think I love it. I just love it.
Pretty good. Yeah. We were experimenting with like, how much information do I need? Because in the engineering field, it's kind of like, a medical doctor that has, what are they called? Nurse practitioners. A nurse practitioner can do a lot of the licensed medical doctor's work, but it's always under their supervision. And professional engineering can be the same way. I can have technicians, I can have unlicensed engineers, meaning engineers that just have a degree, or anybody that I've trained and have that I trust to be able to collect the data for me on my behalf, so to speak. And that's where with Heather, she was doing a bunch of these, and I started by just going out to some of these properties just for peace of mind and good client rapport. And I'm like, I just can't be going to these things if you can take a measurement and give me the information. And so we created these procedures, which now load